Today, I am pleased to introduce today's session from SF with Love, AI Agents and How to Build Them, and our guest speaker, Yujin Tang. Yujin is a senior developer advocate at Zilliz, and he has a background as a software engineer working on auto ML at Amazon. Yujin studied computer science, statistics, and neuroscience with research papers published at conferences, including IEEE Big Data. He enjoys drinking bubble tea, spending time with family, and being near water. Welcome, Yujin.
Thanks, Sashi. Hello, everybody. Today, we're going to be talking about AI agents. So before we get into this, let me take another quick survey of the crowd. Who understood the title? Who got the reference in the title? If you did, you get extra points. Drop into the chat if you did. So I'm going to get into this. So my name is Yujin Tang. I am a senior developer advocate here at Zilliz. And that QR code there to your right will lead you to my LinkedIn. If you scan that, you can follow me to kind of keep up more with everything that's going on with RAG, AI agents, vector databases, LLMs in general, that kind of stuff. Someone asks, where do I redeem these points? You can redeem them in your mind. They're just extra points. So you just know that you are a cultured member of society. All right. So yeah, that's a little bit about me. And then Zilliz is a vector database company. We are the company behind Milvus, which is the world's most popular vector database on GitHub based on number of stars. So today we're going to be talking about AI agents and RAG. And specifically, we're going to be talking about how you can build a RAG application in an agentic way using AI agents with LlamaIndex and Milvus. So the first thing we're going to do is we're going to go over a project overview. We're just going to cover the technology that we're going to use. We're going to cover the way that we're going to put this technology together. And then we're going to cover the different pieces of this project. So first, we're going to cover a little bit about RAG. What is RAG? And then we're going to cover a little bit about AI agents. What are AI agents? How do they work? And then we'll touch briefly on LlamaIndex, which is going to be the orchestrator that we're going to use to create these AI agents. And we're also going to touch on Milvus, which is the vector database that we're going to use for our RAG that our AI agent is going to use to do retrieval augmented generation. And then at the end, I'm going to walk you through a demo that's going to show you how you can build this yourself and what that's going to look like. All right, step one, we're going to do a project overview. So today we're going to be talking about how to build AI agents that do RAG, and we're going to use these three technologies. So we're going to use Milvus. Milvus is going to be our vector database. Milvus is particularly aimed at problems of scale, customizability, and continuous usage. And then we're going to use OpenAI as our LLM. If you haven't heard of OpenAI, drop me a comment in the chat. You will be in the rare minority. We're not going to touch much on OpenAI and who they are. I think if you haven't heard of them yet, I would suggest Google as a good option. And then we're going to talk about LlamaIndex, which is the orchestrator, the framework that we're going to use to tie everything together. And this is a very rough architecture of how things are going to work. So we're going to build RAG, which is Retrieval Augmented Generation, using AI agents. And the way we're going to do that is kind of played out here, listed out here a little bit, right? So we're going to take a request. So at query time, at the usage time, when you're going to use these AI agents, you're going to take a request and you're going to send it to the whole package. And in particular, it's going to get routed to the LLM, which is represented here by OpenAI. And that LLM is going to take your request and it's going to send it and it's going to look at the tools that it has. And then it's going to invoke these tools to do something. And in this case, it's going to have these query tools that it's going to invoke to query Milvus. And before usage, what you're going to do is you're going to take your data, you're going to embed it, and you're going to put it into Milvus so that it can be queried. So first, You're going to take your data, embed it, put it into Milvus, create a tool out of it, and then at usage time, you're going to send your requests to the application, which is going to invoke some of these tools to be able to query against the vector database, do RAG, and then give you a response. All right, so let's talk about RAG. Oh, there's a question. What is the advantage of using OpenAI LLM plus LlamaIndex for agents versus just using OpenAI agents? LlamaIndex is something that you can use to do much more than just create agents. It gives you the ability to route many things together. So we'll actually talk about this very briefly in the section about LlamaIndex. So yes, let me answer this again later. All right, so what is RAG? If you have not heard of RAG, feel free to drop some questions in the chat. If you have heard of RAG, then this will be a refresher for you. So RAG is Retrieval Augmented Generation. And basically what that means is it is something that sounds exactly like what the words would imply. You're going to augment the generation of your responses by doing some sort of retrieval. So a typical RAG architecture looks something like this. Before you do anything, before you do RAG, you're going to take your data and you're going to embed it and you're going to put it into Milvus. So the goal of RAG is to be able to access your data with LLMs. And this is basically the first step, is to just take your data and put it into Milvus so that you can use it. And then you're going to tie the LLM and your vector database together using some sort of framework. So you actually could do this yourself with just prompts and queries and manually and things like that. But LlamaIndex is one of those frameworks that provides us a really nice way to tie it all together. So what you're going to do is you're going to take your question. Once you have your data into a vector database, what you're going to do is you're going to take your question. You're going to ask your question. The LLM is going to take your question and be like, okay, what is this person asking? And then it's going to take that and it's going to form that into something that it can that should be searched for. And then it's going to take that search string and it's going to put that search string into the same embeddings model that you use to embed your data into Milvus. And it's going to search Milvus, your vector database. In this case, Milvus is just the example vector database. It's going to search your vector database for that embedding, for that vector. And it's going to find the closest vectors. And then it's going to return those strings to the LLM. And the LLM is going to say, okay, cool, I've seen the context for this. Now I'm going to structure this in a way that makes sense so I can answer my question. And then I will give a response to the user. So that's the basics behind a RAG architecture. You take your data, you put it into a vector database, you take your question, you ask it to the LLM takes that question, searches the vector database for relevant responses, and then gives you an answer back. Okay, and that's basically all there is to RAG. So if you have any questions about what I just said, please feel free to drop it in the Q&A. Now let's cover what AI agents are. So AI agents, at the core, AI agents are just LLMs that can use tools. That's it. You can think about tools as just functions. So an example of a very, very basic example would be something like calculators. So if you've been paying attention to the news about LLMs, you've probably seen that there's been a lot of, let's say, a lot of noise, a lot of commentary about how LLMs are particularly bad at math. So one example of how you could fix that is you could create a function or a set of functions like an addition function, a subtraction function, multiplication, exponentiation, whatever. And you create these functions, and then you create like a string that says, hey, this is what this function does, this is the input that it takes, this is how it works. And you give the LLM access to invoke these functions, to execute these functions. And then when you ask the LLM question, like what is 5 plus 8, instead of doing the basic reasoning that an LLM would do, it would instead execute some sort of function like, oh, well, I know that I have this access to addition. And since this person's asking me to add things, what I can do is invoke the addition function and get my response and then give you an answer. So that's the basic idea behind it. Essentially, this architecture shows what it's going to do. You take a request, you send it to the LLM. The LLM will send it to some sort of tool set. It will call some sort of tool set. It will go back to the answer from that will go back to the LLM. The LLM will then say, okay, now I can have now I know what I need to form a response, and it will give you a response. Okay, there's a couple questions here. Let me wrap up this section and then I'll address any questions. So, right, the basic idea behind this is that you can give LLMs access to tools in the form of functions, executable functions, and that is how you can kind of patch some of the things that LLMs can't do, or I guess, and extend the functionality of LLMs. And there's a lot of work being done to explore these agentic workflows now. And some of the real life examples could be things such as, being able to do RAG, or being able to search the web, or being able to even create other functions. So those are some examples of AI agents. Let me take the questions now. How can I use a spreadsheet with an LLM to test this process and outcome first? I'm going to need you to clarify what you mean by this question. I'm not entirely sure how a spreadsheet, like what you want to do with a spreadsheet. So can you please clarify this question, and I'll try to answer that. Question about RAG. Okay, so this goes back to the last slide or last section. How do LLMs read the vectors? Do they get a map from the embedding model that is waiting for it in the database? Okay. So let me clarify about how RAG works. So let's go back a couple slides here. So I did not put this into my visual here, and maybe that's my fault here. I should put this visual that shows you like an embedding model and where it should sit. So the LLMs, what they do is they don't read the vectors. The LLM takes the text and it tries to do some sort of reasoning on the text. So perhaps the question you asked is, how big is Seattle? Then the LLM, what it would do is it would be like, okay, I'm looking for Seattle and size or something like that. And it would vectorize, Seattle or size of Seattle or something like that. And it would search, it would vectorize that using the embedding model. It would send that text to the embedding model, and the embedding model would produce a vector embedding. And then that vector embedding would be what is searched for in Milvus. And Milvus would then say, okay, here's the vector embedding model. Along with this embedding model, I have a sentence that is stored here that says Seattle has a population of 750,000 people. And then it would turn that sentence to the LLM, and the LLM would then be able to take that along with whatever context, like, oh, like the greater metropolitan area is 4 million people, et cetera, et cetera, et cetera. And then it would return that answer to you. What are tools examples? So I just gave some tool examples in the AI agents as I was talking about them. For example, a calculator. You can also do RAG with tools, right? You could use query engines as tools. Other tools examples, you can use something that will do like search the web, like a web scraper, or call an API, or anything like that. So tools are just imagine something that you would have to manually do, like, create like some sort of Python function. Maybe it's like, hey, like I want to, I don't know, like I want to multiply these numbers. I want to add these numbers. I want to do RAG. I want to, I don't know, like create an image. Maybe I want to call another model and it'll create an image for me. Like that's an example of a tool. Are there any models that are best to make embeddings for RAG? Oh, this is back to RAG. Okay. Or are there better models for embeddings, or just use OpenAI, or there? Okay. Yes, great question. The embedding model that you're going to use, that you're going to want to use, is going to be dependent on what you want to do. In a basic sense, you can just use OpenAI, but I would say that if you're going to, that's like probably really good for your POC just to get something up and running really quickly. But if you really want to do something customizable that you can put into production, what I would suggest is that you go to Hugging Face and you test out a bunch of their models, their open source models, and you find ones that are best for your use case. So for example, if you're going to be doing text, you're probably going to want something from sentence transformers. If you're going to be doing images, you probably want something from like a ResNet 50 or some sort of vision transformer or something like that. So it's going to depend. And I wouldn't say there are specifically any better or worse models just for embeddings to RAG, because it's going to depend on a lot of what you're doing. So some things you're doing might be, what is it called? Vertical specific. So maybe there are some models that are for finance or for legal or for healthcare or something like that. And you're going to want those specific models. And you can either fine tune your embeddings model for that, or you probably want a specific embedding model, and you probably want to fine tune LLM for that. So yes, it's just going to be dependent on your use case. Can I use a spreadsheet as a tool for RAG, having a product list with prices? If the LLM needs to answer a question on pricing for a product, would it then have the answer? Yes, you can do that. You would need to format it correctly. So, for example, you would need to give the LLM, you have to give instructions on how to search that spreadsheet, or you'd have to have some sort of data converter that can take that spreadsheet and turn it into a JSON or something like that. I mean, you could do it with CSVs, but CSVs have been notoriously difficult to work with for LLMs because they do not follow unless you're using a fine-tuned LLM or a fine-tuned embedding model, because they do not follow the traditional sentence structure of English or any other language for that matter. Suppose I have a PDF on which I want to perform RAG operations on. Now I have some other text file which says that if you find this in a PDF, this is a red flag or a green flag. How do I make sure the RAG follows this text file and find these red flag or green flags within the PDF? I'm not sure I fully understand this question. Here's my interpretation. If I'm interpreting it wrong, you can feel free to update your question. So I'm guessing that you have a set of PDFs and you want to search these PDFs. And you also want to give instructions to the LLM that says, if you find something in this PDF, perhaps you find the word, I don't know, like swag, then it's a green flag, which means that we want this PDF file. And if you find the word not swag, or swagless, then maybe it's a red flag and we want to ignore this PDF file. Essentially, I don't know why you need a text file, but you would probably just pass this in through the prompt. Oh, more RAG questions. Wow, there's a lot of questions about RAG today. Guys, this is an AI agents webinar. Okay, I'm kidding. I can answer your questions about RAG as well. RAG specific question. Let's say we have 100 embedded docs with metadata that states which file each embedding comes from, and there are 10 unique files, so 10 embeddings per document. Is there a way to query the top K, let's say 3 embeddings per unique file? And so in this case, would it return 30 chunks total? That's a good question. There is a way to get unique files and then to get the top 3 from the unique files. So Milvus and I'm not sure what other vector databases can do this, but I can tell you that Milvus can do this. You can call this new function called group by, which if you follow me on LinkedIn, you've probably seen me like rage about this like a couple months ago, because I was like, this is so dumb. But it actually makes sense when you think about unique files. And I think it's really interesting that you've asked this question, which really validates what the team has built on it. So you can get unique files from Milvus, and then what you can do is you can actually get the chunks for those files and then sort those chunks. So the answer would be yes, and it's going to require more customization than a typical RAG application. Oh, another question. Can we do RAGs on order data table, and how to keep it up to date? I don't understand this question. Okay. If I want my agent to be able to handle the cases of forecasting, can I do it? I'm gonna need you to answer this question. It's a, can you do RAG for a live stream of data? Yes, I don't know why you'd want to do that. It's going to be, I mean, like Gen AI, like LLMs are not real time. LLMs are slow. They are not real time. So you can pipe data into LLMs in real time, but it's not going to be helpful for you because the LLM itself is going to be your is going to be your um, bottleneck. This is not really a question, but here's a comment. If I put too many rules into the system prompt, won't it lead to a loss in the middle problem or LLM losing context? I'm worried there's a limit on system prompts. I mean, yeah, but what you can do is you can tag metadata in your vector database and then just do metadata filtering. So when you do your query, you can filter on specific metadata and then you can implement your rules that way. Oh, wow. Oh, there's another question. Wow, I'm getting a lot of questions about RAG already. Okay. Let's assume I'm creating a conversational ERP system. I want my order data to be available through conversational interfaces. How could I go about it? You can just tag your data with a timestamp. And then when you search, you can filter on timestamps. Great. All right. We're going to skip through that. We're done with this. Okay. We'll cover a little bit about LlamaIndex. So what is LlamaIndex? LlamaIndex is a framework for building LLM applications. If you've heard of LangChain, it's somewhat similar. LangChain is focused on how you orchestrate and chain together LLM inputs and outputs. LlamaIndex is focused on how you do better data retrieval and put that into LLMs. LlamaIndex also has integrations with many popular tools, including Milvus, other vector databases, other embedding tools, other LLMs, all of these different things. Okay, so what is Milvus? Milvus is a distributed vector database that's optimized for large, high-scale use cases. So basically, if you're building with more than 1 billion vectors, Milvus is going to be the best vector database for you. We have 50 plus projects with over 1 billion vectors in production. And actually, that was last year, so it might be more than that now. I would bet it probably is more than that now. And a couple other things that Milvus does really well is that it has this really highly customizable set of indexes and distance metrics. If you have more questions about indexes and distance metrics, I have a lot of videos about that, a lot of articles about that. But essentially, indexes are ways that you organize your data and how you're going to search your data. And distance metrics are ways that you compare how far apart your data is. So there's a bunch of different ways to do this, and it's actually really, really important to your application that you use the right indexes and distance metrics for your use case, because there are trade-offs for each of these. And finally, Milvus has a lot of enterprise-ready features, role-based access control, multi-tenancy, all the really boring stuff that nobody really wants to hear about. Unless you do want to hear about it, but you should probably come to another webinar for that. Okay, so let's also take a look at what data in your vector database actually looks like. And then we'll take a look at the architecture, and then we'll go to the demo. So this is what vector data looks like. This is an entry. So you need an ID and you need an embedding. So your ID can be customizable, and your embedding is just going to be a series of numbers. So this is what a vector looks like. I get a lot of questions on what a vector looks like. Here it is. It's a bunch of numbers. That's it. Okay. And now this rest of it is what we call metadata. And metadata is essentially data that you tag onto your vector and your ID so that you can use it at the time of querying, or that you can filter with it, like I was mentioning earlier. Okay, so let's also take a brief look at Milvus's architecture. So Milvus is a distributed system, and it is the input output is loosely coupled in a sense, right? So what we do is we model Milvus as a pub subsystem that uses a stateful coordinator service that will spin up and down stateless nodes. And probably the most important thing for you to understand in terms of vector databases in general and scaling is, why would you have a pub subsystem? Why would you have something like this? So the main reason is you want to have consistency across replicas and across instances. And write consistency and read consistency are two different things that are both incredibly difficult to do at scale. And Milvus automatically handles a lot of this for you through 4 consistency levels that you can choose based on what you need. So this is, once again, in response to the person who asked about the real-time data streaming. You can stream data in real time into Milvus. We use Kafka Pulsar for that. And it's going to depend on your consistency level when and where you can access that. So you can actually have everything read after write. So that's called strong consistency, all the way down to something loose, what we call eventual consistency, that just does everything in the order the system receives it. Some other things to be aware of are this separation of these nodes here. So we have a query node that handles how queries are done. We have a data node that handles data ingestion. And there's an index node, which handles how do I organize my data. So why are these nodes separate? Why do we have a separate node for each of these different things, each of these different functionalities of the vector database? The main reason we have this is because you are never going to see all 3 of these scale at the same time. You're never going to have something where, hey, I'm ingesting like, 300 million documents, and I'm also querying against 300 million documents. Typically, you'll have something that scales different for each one. And this is particularly important because this helps you optimize your resources, keeps your costs down, and also just lets you have more control over the functionality of your vector database. Something that isn't on the architecture, but also important to understand and important for people whose data is going to be changing often, is that Milvus indexes your data into these segments, and the default size is 512 megabytes. But as you get bigger and more data, you're gonna probably want to make that segment size larger. And the idea behind it is basically that if you index and query on these small segments, you're gonna get much faster results than if you were to index on a huge segment. So if you just think about it for a second, the big O of parallel searching 200 segments of the same size is going to be smaller than the big O of saying like, hey, I have this huge amount of data that I want to go through linearly, right? And then the other thing is that as you change your data, as you update your data, as you add more data, then you're going to want to do this thing called reindexing. If you were to build just a proof of concept and you just wanted to put data in and say, hey, I just want you to index over this data, then none of this matters. But in production, in real life usage, the reality is your data changes a lot, quite often, by the minute, by the hour, by the day, by the week, by the month, whatever. Your data is always changing and you're always going to need to update your data. So the reality is that as you update this data, it becomes incredibly hard to index it well unless you have a system that handles that for you. And so that's something that Milvus does as well. And now we're going to get into the demo. So before we get into this, if you have enjoyed this presentation so far, I'm going to ask you to do me a favor and scan that QR code and go give Milvus a star. My boss will be very happy about this. And I'll also pause here to answer some questions. If I want my agent to handle the cases of forecasting, can it do so based on the order of data? Wait, you asked this question already, and the answer is yes. Yes, you can. How do I structure different formats of data while performing embedding? Suppose my PDF contains text data, tabular data. How can the embedding be performed? What do you suggest? So PDF specifically, I'm going to refer you to this thing called Llama Parse. Tell the LlamaIndex people I sent you. Llama Parse is their specific like PDF parsing tool, and it's really fast and it works really well. I like it for PDFs. I'll probably have some projects that showcase it later, but it's something that helps you parse PDFs, and you don't have to worry about any of this stuff basically. Can Milvus solve my problems? Yes, Milvus will solve all your problems for you. You'll never have to think about anything again. Milvus can do everything for you. No, I'm kidding, but I don't understand this question. Can you compare LlamaIndex and LangChain a bit more in depth? Should we choose LlamaIndex over LangChain to work with Milvus? These are fundamentally different libraries. So yes, they're in the same category of library. They're both to help you orchestrate and create LLM applications. But fundamentally, they have different focuses. And I would suggest you use the correct library for the correct focus. So if you want to do something that's gonna involve a lot of retrieval, a lot of data for your LLM, a lot of data that goes in and out of your LLM, then you should use LlamaIndex. If you're going to use something that's going to be a bit more about how your LLM functions and what you do with the inputs and outputs of your LLM, then you're going to want to use LangChain. So these two libraries are different libraries that can perform a lot of the same functionality, but are actually organized as completely different. They have different bases of organization. And so depending on what you want to do, you should choose your library based on what you want to do. What is the main benefit of Milvus versus, okay, so relational databases, for example, don't do what vector databases do. And actually vector data, I'm going to go back a slide here. So vector databases are actually, vector database is a bad term. It's just what everybody tends to call them, but what they actually are is a compute engine. So if you want to, you can build a compute engine on top of your relational database, but why go through all that trouble when you're going to run into performance issues? Because then you won't have, the ability to scale, the ability to spin up multiple instances. You won't have proxies. You won't have the ability to separate your concerns and all these different things. So look, if you have 1,000 pieces of data, it doesn't matter what database you use. It's completely irrelevant. But when you want to go into production and you have something that's going to scale, that's when you want something that's going to be purpose built for your use case. And Milvus is primarily built to serve that use case of people who are really going to take things into production and want to have huge amounts of data they're going to be touching. That's when Milvus is going to be useful for you. So if you're just playing around with it, I would suggest, it doesn't really matter. Maybe play with Milvus for fun if you'd like. Can agents perform multiple tools with RAG operations in between tools? Yes, you just have to structure it that way. Can Milvus support multiple embeddings in the same indexed? No, you cannot do that because embeddings can only be compared if they are the same length. If embeddings are not the same length, they cannot be compared mathematically. I want to have an LLM and custom data generated by the user. Is RAG good for that? Yes. Why would you use Milvus instead of Pinecone, Quadrant, or Weaviate? I think I just answered this question earlier. Milvus is the only one that's distributed. Really, you can use any of these if you're, like I said, if you're playing with small amounts of data, use whatever you want. It doesn't matter. You can create your own vector database, vector search engine, and use that. Like it really doesn't matter when you're working with small amounts of data. It only becomes something that matters when you are looking to build something that's going to go into production and that's going to be enterprise ready. Great. Okay, so let's just let's give a refresher on what we're going to look at, and then we're going to get into the demo. So remember, we're going to build RAG with an AI agent. I know we just asked a lot of questions about RAG. I just answered a lot of people's questions about RAG and like briefly touched on AI agents and how you can things work. But in this specific example, what we're going to do is we're going to build an AI agent that does RAG for us. Okay, and we're going to use OpenAI because it's easy, because it's simple, because it's there. And we're going to use some PDFs. So those of you who are asking about PDFs, very relevant questions, we're going to be using PDFs. So we're going to be using the 10Ks of Uber and Lyft. Okay, so let's get to it. All right, so here we're going to look at this. So I will, here, let me drop the link to this below so you guys can get this. Oh, here it is. So this is one of the notebooks in my AI agents cookbooks repo. And essentially what we're going to do here, like I said earlier, is we're going to create an AI agent that does RAG, and we're going to do RAG on the PDFs of the 10Ks of Uber and Lyft. Oh, before you jump into the demo, can you give us a light recap about AI agents? Is it just executable functions? The answer is yes. Basically, that's how it works. It's a little bit more complicated than that, but you will see in the demo about how that works. All right, so let's jump into it. The first thing we're going to do here is we're going to, first thing we're going to do here is we're going to download a bunch of data. And then actually, before we do this, we're also going to run docker compose up-d, and you can get the Docker compose file for this in the repo. I've dropped the link in the chat, so you can go there, get that Docker compose file, pull that, and do this. So I've already run my Docker compose files. My container is already running, so I'm not going to run this piece. All the data is also all in the repo, so you actually don't need to run this stuff. But if you want to download it yourself, you want to do it from scratch, you can do all this stuff. So the core imports we're going to look at here are the simple directory reader, which is LlamaIndex's way of just reading in a directory, and then vector store index is their way of accessing vector databases, and then storage context is the way that you pass around different ways to store data. It's the context for storage in LlamaIndex. And then we're also going to get the query engine tool. So readdressing someone's question about executable functions inside of LlamaIndex, as well as inside of LangChain, by the way. The way that you access tools, the way that you access these functions is based on a specific type of class, object, whatever that they have made. And tool metadata basically tells the LLM, gives the LLM some sort of metadata to your tool so that you understand, so that it understands how to access and how to use your tool. And then there's Milvus Vector Store, which is going to be LlamaIndex's way of interacting with Milvus. So this next section is probably going to take the longest. And basically what we're doing here is we're getting all the data and we're vectorizing it and we're putting it into a vector database. So let's step through this step by step, right? The step here is we're going to call the simple directory reader, and we're going to use that to read in these files. And so in this case, we've got a 10K file from Lyft from 2021, as well as a 10K file from Uber in 2021. And we're going to use the simple directory reader to read in both these files as sets of documents. And so we've called these Lyft docs and Uber docs. And now we're going to build indexes. And so in this case, we're going to create one for Lyft and one for Uber. And here you'll see that I've passed in 1536 as the dimension. Dimension just refers to the length of the vector. And this is going to vary depending on your embedding model. In this case, because we're using the default embedding model of OpenAI, OpenAI has a dimensionality of 1536. So we're going to pass in 1536 as our dimension. Next, we're going to name our collection. And so in this case, I've just named the Lyft collection Lyft and the Uber collection Uber. And overwrite equals true just means, hey, if I run this again, I want you to overwrite the database. And now what we're going to do is we're going to give it the storage context, right? So here we've created these access to these connections to the vector database. And now we're going to use a storage context so we can pass this connection around inside of LlamaIndex. And we're just going to say, hey, we want to pass this vector store. And the vector store we're applying is Lyft or Uber. And then next, we're going to create a vector store index, which is the way that LlamaIndex interacts with these vector stores and the way that they're indexed. So vector stores can create multiple indexes for multiple, you can create multiple indexes for multiple types of vectors. So Milvus has recently introduced this thing called multi-vector search, which allows you to have multiple vectors inside of the same entry. You can't compare these vectors to each other. Like you can't compare vector 1 to vector 2, but you can compare vector 2 across a set of vectors. And in that case, that would be a different vector index than vector 1. And now what we'll do is we'll pass in these Lyft docs, these Uber docs, and we'll create a the index on these. And so you'll notice here that all we're doing is creating the connections to the vector store to Milvus. And then here we're actually creating the embeddings for the documents and inserting them into Milvus. And so this step here is actually the step that's taking this function so long to run. And then we're just going to persist this into certain directories. So this is optional. But essentially what this allows you to do is this allows you to say, hey, if I come back and I want to work with this again, I can load it from these persistent directories. Now what we want to do is we want to take these indexes and we want to turn them into query engines. So a query engine is just a way to interact with a vector DB and search that vector DB. And the main thing we're going to apply here is the similarity top K. And what this means is that we're going to get our results back, the top 3 results back here, right? So similarity top K equals 3. And that's all this means, okay? And now this is where we start creating the tools. This is how we pass in the ability to execute these tools. And so what we do is we create these and we turn them into query engine tools. And we give this thing a Lyft engine, which basically just we called this query engine for Lyft as the Lyft engine and the Uber one Uber engine. And so we need to pass in the query engine for the query engine tool to have the ability to query the vector database. And then we also need to pass in some metadata. And the metadata here is actually how the LLM understands how to use this tool. And so, you know, this is basically in the sense of, yes, this is just executing a function, but the name, we give it a name so that it knows like, oh, like this is what I should call this. And then we give it a description. And in this case, we say, provides information about Lyft financials for the year 2021 and use a detailed plain text question as input to the tool. So in this description, we've told the LLM what the tool does and how it can use the tool, okay? So this is important because this is basically LLMs are doing reasoning on text, and this is how it's able to understand what tools to use as an AI agent. Did I already run this? Okay, I already ran this. Okay, now we're going to create the actual agent. So in order to create the actual agent, we're going to import this thing called the React agent, and we're going to import OpenAI. We've actually already used OpenAI in the vector database, but we're going to import OpenAI as the LLM. And the React agent is just reasoning action, React. Okay, and then here, we're going to import the model. So we're just going to say, hey, the LLM that we want to use is GPT 3.5, 3.5 Turbo 0613. This is just a version of GPT 3.5. If you have access to GPT-4, you can use GPT-4. And then we'll create the agent, which is going to be the React agent. And we're going to create it from a set of tools. And so we created this list of tools earlier that we called query engine tools. So if you want to do things other than RAG, if you want to do things other than querying, you can pass in other tools. And then we're going to give an LLM. And we're going to just say verbose. We're going to do this in a verbose manner, which means that when we call the LLM, it's going to output its reasoning. So we're going to call the LLM, and we're going to hope that it gives us Lyft's revenue growth in 2021. Okay, great. And so this is a function of the verbosity. It says, I can use Lyft 10K tool to find information about Lyft's revenue growth in 2021. And the action it's going to take is the Lyft 10K. And the input to that action is the question, what was Lyft's revenue growth in 2021? And then it's going to give you the observation that it makes here. Lyft's revenue increased by 36% in 2021 compared to the prior year. And then it takes that observation, it goes back to the LLM and reasons, I have the information I need to answer the question. Here's the answer. Lyft's revenue growth in 2021 was 36%. Okay, so that is the base of the demo. That's really it. I understand that there was a lot of code here to kind of get through rather quickly. So if you have any questions about that, we can answer those questions. I see there's also 2 questions in the QA already that I will go ahead and answer. Any tricks on how to get relevant entries from Milvus to questions like what is the biggest, smallest, etc.? Questions where an unknown number of entries have to be compared to get the right result. In this case, you probably wouldn't want to just so Milvus, what it does is it's a vector database, and vector databases are ways to find semantically similar data. And so in this case, what you're asking for is actually not semantic similarity, but something that can be done through comparisons, which is much easier done through something like a Python script. However, in the way to do this is to use metadata filtering, where you can say, hey, like maybe you want the longest entry or the shortest entry, or you want the entry with the most number of commenters or something like that. In that case, what you would do is you would just use a metadata filter to like set like a boundary, and then you would use some sort of re-ranking mechanism to rank these in order of whatever. So the biggest comment about the longest comment about I don't know, like elephants. And in that case, like what you would do is you would search for elephants and you would get back a bunch of results, and then you would find the longest result, something like that. Can you use a different embedding even if you're working with an OpenAI LLM? Yes, you can. And can you explain again multi-vector? Okay. Multi-vector is if you have multiple ways to represent an object or an entry, then you could have multiple vectors that represent that entry. So for example, let's say you have 3 different embedding models and they have different dimensionalities, like they have 384, 768, 1536. What you could do is you could have all 3 of these embeddings stored, and then when you want to compare, you can compare based off of any of them, but you have to ensure that you compare off of the same vector embedding each time. So you can't compare the 384 to the 768 or the 1536, but you can compare different 1536 dimensionality vectors to each other. Where will I be able to find this recording? Sachi, this one's for you.
We'll send you the recording if you signed up through email, and it'll also be on YouTube shortly after the webinar is over.
How do the tools work under the hood? Does the usage of a tool by the LLM means that the LLM sends back an answer with the name of the tool and the search text, and then the library handles that on my machine and sends the answer back to the LLM? Okay, wait, let me reread this. So the LLM basically sends the input into the function and then gets the output out of the function. The function I think the question you're asking here is, where does the function execute? And the function will execute locally, either server side or client side. I guess that's not locally. It will execute wherever the function is hosted. So if you're running it on your machine, it will execute on your machine. Yes. Would you have a separate index for each embedding model for the multi-vector scenario in one vector database? Would you have a separate index for each embedding model? Yes, you would. Yes, because indexes are ways that you access the data, and you can only create indexes on vector embeddings of the same size because you need to be able to of the same dimensionality, because you need to be able to mathematically compare the vectors. And yes, you could all store it into one vector database. At least you can do it with Milvus. Once again, I can't comment on what other vector databases can do. Something about low code. So I don't know, like, yeah, like you can use low code in Zill's Cloud, like sign up for Zill's Cloud and just give it a bunch of upload documents. There's pipelines now. Zillow Cloud has this thing called pipelines. All you got to do is you upload your documents. It'll embed it for you. It'll put it into the vector database for you. So if you don't know how to program, I would consider learning how to program. I don't know if you saw the thing about Devin, but Devin said like, they indexed it. They were like, oh, we solved like 13% of issues. And then like recently people found out that that was like not true. So programming is not going away anytime in the near future. And if you want to be able to build custom things, you're going to have to learn how to program. By the way, yeah, that's really this is my only real comment about this. No code or low code is just someone else's code. So if you want something customizable, you're gonna have to make it yourself. Do you think using multiple query engines is a good replacement for the Milvus group by function you had mentioned earlier? These are fundamentally different use cases. So multiple query engines is if you want to query multiple databases, and group by is if you want unique results from the same set of if you want unique documents from the same set of documents stored in this in one vector collection. So I guess my answer is no. These are different use cases. Cool. I think we were able to wrap this up in a good amount of time. It looks like we've been able to address all of the questions, and we still have 5 minutes left, and we got to run through the entire code. So I'm happy to wrap this up here. If there's any other questions, I think we can give it like 30 seconds and speak now or forever hold your peace.
Yeah. Anyone have any last minute questions to ask Eugen before we wrap this webinar? Just wait a few seconds here. Also, again, this recording will be available to you shortly after the webinar, so stay tuned for that. Looks like you have one question.
I do. Show your LinkedIn QR code again. Yes, I can do that.
We also have a Discord channel. I will put that in the chat again for anyone who missed it earlier.
Okay, there it is. You can scan that and you can find me on LinkedIn. Can we contact you for further questions later? Yes. Go find me on LinkedIn, comment, tag, make a post, tag me in the post. I can answer your questions. If you were to take a devil's advocate for using vector DBs for efficient RAG, what would you say? You can't do RAG without vector databases, so I don't know how to answer this question, to be honest. I would say yeah, I really don't know. Like the whole point of the whole concept of RAG relies on you having vector databases. Okay, I think that is a wrap.
Yep.
Oh, never mind. There's another question. Okay. For the tools, could an agent read an email and synthesize information from it, and then go search the web and an action? Yes, it can. You will have to have multiple tools, each of which does one of these tools. Each of these does one of these things. For example, an email reading tool and a web search tool and an action, and then you could have all of these chained together. I guess you could have it all in one function. But I mean, the answer is yes. It just depends. You can do it in many ways. All right. Before we say this is a wrap again, I'm gonna let someone else finish typing their questions. And here's another question. If I had all the unique files in separate indexes, so I wouldn't be able to use a group by on one index, but I want to go over what? But I want to be going over multiple indexes. Could this multiple query engine work to check multiple documents instead of using group by? Okay, wait. Unique files and separate indexes. So I wouldn't be using group. Yes. Yes. You could do that, and you would probably just want to pass different indexes to each query engine. Okay. Any last minute questions here? Okay. This looks like we're good. Oh, what's this? Oh, okay. Okay. Oh, okay. This was just a thank you for the question. Well, thank you, Alex.
Okay, thank you all for joining us today. Have a
See ya.
good rest of your day. Bye.